So we've mentioned several times about the relationship between the valence electrons of an atom and the reactivity of an atom. The valence electrons are the electrons in the outermost principal shell, and these are the ones that are available to interact with the atoms nearby. Since these are the electrons that we are interested in, this is what the Lewis theory focuses on. In Lewis theory, the valence electrons of main group elements are represented as dots surrounding the symbol of the element. The result is what's called a Lewis structure or a dot structure. Remember, the number of valence electrons for any main group element, except for helium, which has 2 valence electrons but is in group 8A, is equal to the group number of the element. So what's the electron configuration for oxygen? Take a minute, go back to chapter 9, see if you can write down, come up with the electron configuration for oxygen, and then come back. The electron configuration for chapter 9, or for oxygen, is going to be 1s2, 2s2, 2p4, which indicates that there are 6 valence electrons in that outermost shell. Each dot, so since we have 6 electrons in our valence shell, we are going to draw our Lewis structure as oxygen, or O, the symbol for oxygen, and we're going to place those electrons around the outside of the shell. The dots are going to be placed around the element symbol with a maximum of 2 dots per side. Although the exact location of the dots is not critical, we fill in the dots singly first and then pair them up. It's important to follow this convention when doing your homework. So let's take a moment to practice by writing the Lewis structure for phosphorus. Since phosphorus is a group 5 non-metal on the periodic table, it has 5 valence electrons. We're going to represent these as 5 dots surrounding the symbol for phosphorus. So it should look something like this. Lewis structures allow us to easily see the number of valence electrons in an atom. Atoms with 8 valence electrons, which are particularly stable, are easily identified because they have 8 dots, or what we refer to as an octet. Again, the only exception for this is going to be helium. Helium contains 2 paired dots, a single duet. For helium, the duet represents a stable electron configuration. So that's going to be what our Lewis structures look like for individual atoms. Please let me know if you have any questions, comments, or concerns.